So today, as we work with our ratios, rates, and proportions, okay, we're going to fit those pieces together and be able to solve and apply proportions. In your interactive notebook, first piece we're going to look at is that ratios piece. So if you open that up, the top portion says a ratio is a comparison of two or more numbers. A comparison of two or more numbers. Most of the time in algebra, when we are working with ratios, we are going to be comparing two numbers. Right? But you can compare more than two. An example that you see in the center of your piece says the ratio of stars to circles is 2 to 3. Okay. With ratio, order is very important. So because they said the ratio of stars to circles, okay, stars have to be first. There's 2 stars. And then our circles was the second piece. There are 3 circles. So order is very important when we are working with these ratios. Then the you should know. There are 3 ways to write a ratio. So if we look at this from the example that they gave us, they used the 2 to 3. So one way that you can write a ratio is using the word 2 in between. You can use a colon. When you read it, you still read it as 2 to 3, but they use a colon instead of the word 2. And then the other way that a ratio can be written when you're comparing just 2 numbers is as a fraction. Okay? And the first term of that ratio needs to go in the numerator of the fraction. So again, that's one reason why most of the time when we work with ratios in algebra, we are comparing just 2 numbers, because to do any calculations with our ratios, we are going to be writing them in that fraction form. So when we're talking about a ratio, basically we're talking about a fraction. A fraction is a ratio. The next piece in your interactive notebook, rates, says a rate is a ratio comparing 2 numbers with different units. An example says a car travels 100 miles in 2 hours. So it's 100 miles in the numerator, 2 hours in the denominator. So we're seeing different units. So another place other than math that you might work with different rates would be in your science classes. And I know you guys do a lot of unit analysis and those kinds of things in your science classes. So you're working with different rates. On the you should know part, a unit rate tells the rate in lowest terms, or the amount for 1. And it's always that denominator, that bottom piece, that we want to make a 1. So in the example, they did that. If we're going 100 miles in 2 hours, we want the unit rate for 1 hour. So I had to divide by 2 in the denominator to get 1 hour, which means I divide the numerator by 2. 100 divided by 2 means my unit rate would be 50 miles in 1 hour, or 50 miles per hour.
If you can't divide, or if you can't simplify it down anymore, and it's not in 1 on the bottom, you want us to still do it, but
you would divide by whatever this is. It doesn't mean that it has to go in evenly into the numerator. So if this would have been 100 miles for 3 hours, okay, we'd have to divide both of them by 3 to get the 1 hour. So 100 divided by 3 would be 33 1/3 miles per hour. So yes, for a unit rate, it has to be 1 for the denominator. Okay. So a rate is just a certain kind of ratio that has different units. A ratio is simply a fraction comparing 2 numbers. Then proportions. A proportion is an equation, and we just finished up our unit on solving equations. We're going to continue to work with equations because we're working with proportions. So a proportion is an equation showing 2 ratios are equal. So if it's showing 2 ratios are equal, again, we said ratios are fractions. So in the example, 10 over 25 is equal to 40 over 100. Those are what we call equivalent, which means equal, equivalent fractions. Neither of them are in simplest form. They are equivalent. If we simplified both of them, they would simplify to that same fraction in lowest term. On the you should know section, it says in a proportion, if the ratios are equivalent, then the cross products are equal. In a proportion, if the ratios are equivalent, then the cross products are equal. What does the word product tell us? We're multiplying. So to check, to make sure this is equivalent, these 2 fractions are equivalent, we can cross multiply. When I cross multiply in one direction, I take 10 times 100. What do I get? 1,000 equals, I cross multiply in the other direction. What's 25 times 4? 100 times 10 is 1,000. So if the ratios are equivalent, if my fractions are actually equivalent, then my cross products, when I cross multiply, would be equal, which is what I see there. On the next page in your interactive notebook, we have those 3 different pieces that were glued in that have some different problems on them. we're going to take a look at. So you can actually open up the problem and work it out on the inside. So you see the problem on the outside, open it up, work it on the inside. So this problem says the ratio, so we're working with ratios, the ratio of teachers to kids is 1 to 15. There are 675 kids. How many teachers are there? So first thing we want to do is take a look at that ratio. Okay, we're going to write it in a fraction form. The ratio is teachers to kids. And again, I said order is very important. Okay, so I'm going to use T for teachers and K for kids. So before I start setting up fractions with numbers in them, okay, I'm off to the side going to put a T in the numerator and a K in the denominator, so that when I do set up my proportion, that I'm matching up things correctly. Okay, so teachers has to go in the numerator, kids in the denominator. The ratio they give me is 1 to 15. So for every one teacher, there are 15 students. One teacher, 15 students, or 15 kids. Now they tell me there are 675 kids. So 675 needs to go in the denominator. The numerator, how many teachers, is what I'm trying to find. How many teachers are there? So I'm going to use that variable T. And these two need to be equal to each other. So I have set up a proportion. Two fractions equal to each other are a proportion. So now that I have my proportion set up, I'm going to cross multiply. So when I cross multiply in one direction, 1 times 675 is 675. Equals, cross multiply in the other direction, 15 times t is 15t. Now I have an equation, just like I did in the last unit, that I know how to solve. So what am I going to do to get that t by itself? I'm going to divide both sides by 15. So 675 divided by 15. 15 doesn't go into 6. How many times does 15 go into 67? 4 times. 4 times 15 is 60. How many times does 15 go into 75? 5 times. So 45 teachers. Need to make sure you label your answer. So if there are 675 kids, there should be 45 teachers. Next problem. Be writing this down. The ratio of games won to lost is 3 to 2. So again, we've got a ratio. We're looking at wins and losses. And that ratio is 3 to 2. Second statement says the team won 18 games. So that 18 needs to go in the numerator. We're looking for how many they lost. So again, we've set up a proportion. So we're going to cross multiply in one direction. 3 times L equals other direction. 2 times 18 is 36. I want the L by itself, so what am I going to do? Divide both sides by 3. And so they had 12 losses. Next one says Corey earns $52.50 in 7 hours. Find the unit rate of money per hour. So this time we're doing a unit rate problem. So we're going to take that amount he owes, we're going to write it as a ratio, 52.50 over 7. We want to find the unit rate per hour. So for 1 hour, okay, so if we want the denominator to be 1, that means we're dividing by 7. So $52.50 divided by 7. How many times does 7 go into 52? 7 times 7 is 49. How many times does 7 go into 35? 5. So that's the solution I get, but I need to write it as a unit rate of dollars per hour. So my answer is going to be $7.50. And we need to make that answer look like a money amount. So $ and add in that extra 0. Our next problem, 53.5 hot dogs were eaten in 12 minutes. Ugh. How many of you could eat 53.5 hot dogs in 12 minutes? Anybody that would like to try? No.
If you bring the food.
If I brought the food, if I brought 53.5 hot dogs, you'd try to eat them, Nathan?
Yes.
All right. So let's find the unit rate of hot dogs per minute. So hot dogs goes in the numerator. The minutes go in the denominator. We want to find that. What? Oh, my goodness. I don't know where I got 15.5. 53.5. So again, we want a unit rate, okay, of hot dogs per minute. So we want it to be 1 minute, which means we have to divide by 12. So 53.5 divided by 12. How many times does 12 go into 53? 4 times. That's 48. So we subtract 55. How many times does 12 go into 55? 4 times. 48. Subtract. Got a 7. Bring down a 0. How many times does 12 go into 70? That's 60. We get 10. Bring down another 0. How many times does 12 go into 100? 8. 8 times 12 is 96. Add a 0, bring it down. How many times does 12 go into 40? 3 times. 12 times 3 is 36. I ran out of room. I get a 4 again. Okay, I'm going to keep getting that. It's just going to keep repeating. Okay, so we're going to round it to the nearest tenth. If I wanted to round to the nearest tenth, what would my answer be? 4.5. If I'm rounding to the tenth, I have to look one number to the right. If it's 5 or more, I round up. So about 4.5 hot dogs each minute. Then the rest of our problems are already set up as proportions. You'll see a variable. So we're going to still cross multiply, set up an equation to solve. So cross multiply 5w equals 9 times 3 is 27. So what do I do to get the w by itself? Divide by 5. Can I simplify 27 over 5? Cannot, so I can just leave it that way. Our next one. Key thing that we need to remember here, okay, is we have to think about order of operations. This whole numerator, x minus 1, even though there's 2 terms, that represents one number in my numerator. So that has to be grouped together. So when I cross multiply, I have to take 5 times the entire parenthesis. Equals, same thing happens in the other direction. So anytime you see a plus or minus sign in a numerator or denominator of a fraction, group it together in your parentheses. So in my other direction, 3 times the quantity x plus 1, which means I need to distribute. So I get 5x minus 5 equals 3x plus 3. Variable on both sides, so what do I want to do next? I'm going to subtract 3x from both sides. Whoops, that one shouldn't go away. That would be 2x minus 5 equals 3. What's my next step? I'm going to add 5 to both sides. 2x equals 8. Last step. Divide by 2. X equals 4. Again, you should check your work. If x is equal to 4, 4 minus 1 is 3. So I have 3 over 3, which is 1. If I put 4 in on the right side, 4 plus 1 is 5. 5 over 5 is 1. Same answer on both sides of the equation. Next one. Again, before I even start the problem, I'm going to group my x plus 10 together. So when I cross multiply, 8 times 12, 96 equals 1 times x plus 10 is just x plus 10. I want the x by itself, so I subtract 10 from both sides and get 86. Again, you can check your work. 86 plus 10 gives me 96 over 8. And if I divide that out, 8 goes into 96 12 times. So I would get 1 over 12 on both sides. This one, when I cross multiply, I have to take 3 times that whole parenthesis equal to 1 times the whole parenthesis. So the left side, I need to distribute 3x minus 9 equals x minus 5. So again, I've got a variable on both sides. What I'm going to do first? I'm going to do what? Subtract x from both sides. 2x minus 9 equals negative 5. Next step, add 9. 2x equals a positive 4. Divide by 2. So x equals a positive 2. If I check my work, I have 1 over 2 minus 3 is negative 1, which gives me an answer of negative 1. On the right side, if I put 2 in place of x, 2 minus 5 is a negative 3. 3 divided by negative 3 is negative 1. So always good thing to do, check that work. And then this last one, again, we're going to have distribution. 2 times the quantity 5t minus 3 equals negative 2 times the quantity t plus 3. So I distribute and get 10t minus 6. On the right side, I distribute and get negative 2t minus 6. So what am I going to do to solve? Dominic? I'm going to add 2t to both sides. 12t minus 6 equals negative 6. Next step, add 6 to both sides. 12t equals 0. Next step, divide by 12. Okay. And 0 divided by 12 is 0. Okay. Common mistake, for some reason, when we get a 0, people want to think that it's no solution. Okay, our variable did not disappear. Our solution is 0. If I check my work, 5 times 0 is 0, minus 3 is negative 3 over negative 2. A negative divided by a negative makes it a positive. Okay? What are we doing, guys? We're not going anywhere. When I put 0 in on this other side, 0 plus 3 is 3 over 2. Same thing on both sides of the equation.